Okay, so here is one of the super new kind of hard problems, but if you break it down, it should be fine. All right, let me see how this is going to look. So a lady pushes a 200 Newton couch in an attempt to redecorate her living room. She pushes with a force of 75 newtons, and the friction between the couch and the carpet is 35 newtons. The mass of the lady is 60 kilograms. What is the acceleration of the couch? Okay, so first thing is not to panic. Start and break it down step by step. All right, so you know that your number one thing to do is always draw your interaction diagram. So we're going to have the lady and the couch. Make this a little bit wider. Okay, the couch and the floor. The lady and the floor. Oops. Okay, the lady and the earth and the couch and the earth. Couch, earth. Why this pen does not work? Okay. All right, so let's see. Okay, so there's the interactions. So let's just start by trying to make the diagrams and see where it goes. So we have the lady over here and the couch over here. All right, so the first thing you know you can always put is the force of gravity, because that is always going to be there. So we have FG lady earth, okay, and we have FG couch earth. All right, so let's go up and see if we can figure out, different pen. Let's go back and see if we can figure out what their weights are, okay? A lady pushes a 200 Newton couch, all right? So when it's described like that, that is giving you the weight of the couch. So that's 200 Newtons, all right? So I know up, we have to have a balancing force from the floor, also of 200 Newtons, okay? All right, and then we're gonna have the mass of the lady here we see is 60 kilograms. So if her mass is 60 kilograms, we know her weight must be 600 Newtons. And then she has to have a balancing normal force, lady floor, also of 600 Newtons. Okay, so this should all be basic stuff that you should already kind of know how to do, all right? Okay, so what other forces are acting? So we see that the lady and the couch are having an interaction. So this is going to be our force pair, all right? And on the quiz, this was something that a lot of people had trouble with, was getting things on the right picture, okay? So the lady is pushing the couch, all right, with a force of 75 newtons, all right? So if the lady is pushing the couch, who is feeling it? Right? The couch is feeling it. So that is a force that goes on the couch diagram. So there's a normal force on the couch from the lady of 75 newtons. Okay, because the couch is feeling that. All right, that's a pair because see, I have L and C as my feelers here, and here's L and C as my feeler-dealer pair. So I know that this is going to be my pair. All right. So if the lady pushes the couch to the right with 75 newtons, so let's write that up here for the pair. Fn couch from the lady, 75 newtons this way, okay? The pair force is gonna look like same force type, feeler dealer are gonna swap. It's still 75 newtons, but it's this way, okay? So let's put this on the lady's picture, because she is feeling a force to the left from the couch pushing her. Lady couch, 75 newtons. I don't know why this pen is so hard to write with. I hate this tablet. Okay, all right, so that's the other half of my feeler-dealer pair. All right, there they are. Okay, now, in the good old days, back when you thought things were hard, but now you're like, oh, it wasn't that hard, you just put 75 on either side of this and you're finished, right? I'd put 75 force of friction, 75 here, force of friction, I'm done. Everything's balanced, okay? But now it's not balanced because they're asking us to find the acceleration of the couch, which means the forces are going to be unbalanced, all right? So we know we're still gonna have friction, but in order for the lady to accelerate this direction, okay, she's gonna speed up, we see that this force is gonna have to be bigger. So that's lady on the floor, okay? And for the couch, if the couch is going to accelerate and get faster to the right, we see we must have a smaller force of friction in this direction. Force of friction couch, floor. Okay, so those are the forces that we don't really know. We have to figure that out. So if it's not given, we have to look somewhere else. So let's see first if anything's given. So we know the lady has a force of friction with the floor, and the couch has a force of friction with the floor. So let's look up here and see if there's any other information. Okay, she pushes with a force of 75 newtons, and the friction between the couch and the carpet is 35 newtons. So there it is, okay? So this is the couch, and the carpet is gonna be 35 newtons. Okay, so we can clearly see we were right. This is gonna have to be smaller because the 75 has to win because it's gonna be accelerating to the right. Okay, so if we're solving for the acceleration of the couch, okay, remember we have net force equals ma, okay, or I can switch this around in the other version, right? But this is the same equation, so don't think it's too, oh my God, why is this so hard to write? Forget it, you know what it says, okay? All right, so the net force is 75 newtons minus 35 newtons, right? Because it's going to be everything to the right minus everything to the left. So that's going to be a net of 40, okay? Divided by the mass of the couch. Okay, now, they gave the force of gravity of the couch as 200 newtons, all right? But I want to know the mass of the couch, so I have to calculate that first. Okay, you don't really have to show this work, I don't think. Like, if you can do it, just be careful, okay? So the mass is going to be 20 kilograms. Okay, and mass is always less than weight. So if you, for some reason, have 200 and you end up with 2,000 kilograms, that's not right. The mass is always less, right? Because there's 10 newtons of weight for every 1 kilogram of mass, okay? So I'm going to go ahead and fill in my mass. God, why is this so wrong? Oh, God, please. 20 kilograms. Okay. So that's going to be 40 newtons divided by 20 kilograms. So that's going to give me, why is this so freaking out? Acceleration of 2 meters per second per second. Okay. So there goes the acceleration of the couch. All right. I don't know why this is so bad. Okay. All right. So now we know the couch is accelerating with 2 meters per second. So every second it's gaining a speed of 2 meters per second every second that passes. Okay. I have to pause this because this pen is like not working. Hold on. Okay. I think I worked it out. Okay. I don't know what was wrong with it. Okay. So if the couch has an acceleration of 2 meters per second, the lady has to have that also because they're connected. So the couch can't accelerate faster than she does because then she couldn't push it anymore because it would be ahead of her, okay? So they both have to have the same acceleration. So I know that the lady also has to accelerate, so I can find her net force, okay? So F net equals ma. This is now for the lady, okay? Her mass is 60 kilograms, okay? Her acceleration is 2 meters per second. So we can see her net force is supposed to be 120 newtons. Okay? All right. So be careful because this is what we were trying to do on the board the other day. I need to know her force of friction. Okay? The couch pushes her back with 75 and the net force has to be 120. So that means the difference or the winning side has to win by 120. So in order for that to be true, this force of friction is going to have to be 195, right? Because 195 minus 75 is going to give me that net force of 120. Okay, and then we can circle this. Both of these are unbalanced because they're both accelerating. Okay, now on to the motion stuff. All right, I'm going to kind of run out of space in my little thing here, but we'll do the best we can. Okay, so let's label this. This part is not going to be on the test next week, but it will be on the final. Okay, so the one on the final, you should expect to look almost exactly like this, I think, one of these kind of problems, okay? All right, so if the initial velocity is 0, and I know it's accelerating 2 meters per second every second, okay? This is gonna then increase the velocity each time by 2, okay? And you can write the units. I can't, this pen is like not cooperating, all right? Okay, so 1, 2, 3, 4, 5, 6. Okay, you're gonna label all this really nicely, but I'm not because my pen is a disaster. Okay, and then I'll have 2, 4, 6. I don't think you can see the, let me see if, I don't want to move it. Okay, right? So you're going to have to maybe have this part on your own. Okay, so 1, let's label this by 4, 8, and then the top one is 12, but I don't think you can see it on mine. Okay, so 1, it's at 2. 2 is at 4. At 3, it's at 6, etc., etc., and then you can, boom. Okay? All right? Okay. Now, reminder, to get to the position graph, you have to use the area. Okay? If you look on Miss Wiles' videos, she's doing something slightly different with the average velocity, which is also fine. Okay, maybe easier than the area, but I didn't really show that to you. Okay, so you can just go with the area if you want. Okay, so each of these little triangles, okay, has an area of 1, right? Because it's 1/2 base times height. So it's 1/2, the base is 1 second, the height is 2. Okay, so that means each of those little triangles has an area of 1. Okay, and then this is going to be 2, 4, oh my God, nightmare, 6, 8, etc. Okay, all right. So in the first second, if it's starting at a position of 5, the area here is 1. Okay, so that's going to be 6 meters. All right. The next little area of this piece is going to be 3, so that's going to get me to 9 meters. Okay, then 5, 7, 9, 11. Can you see the pattern? And it always follows this nice pattern, okay? So it's going to be plus 5, plus 7, plus 9, oh my God, and plus 11, okay? All right, so this is just review. You can make the motion map. I can't deal with this pen. All right, so if I go, let's see, I think I did each of these just by 10, 20, 30, 40, right? Okay, so the first one is going to start at a position of 5. Then it's going to go 6, 9. See, it's all crunched in there. Then it'll start to spread out a little bit. 14. What is wrong with this? Okay, I know what I'm going to ask Santa for. 21. Seemed to work okay the other day, though. 30. And then 41, okay? So this should make a nice parabola. Okay, this should make a nice increasing parabola because we know the guy is speeding up. So same thing with your motion map, right? You can quantify it, okay? But it should basically look like it's speeding up, okay? But you can do that, okay? All right, so in addition to this video, there's 2 that I'll post that are different problems that are in the packet that Miss Weil made. So I would watch all of those, do the best you can, and then try 2 through 4. Okay, and I'll also post an answer key of those, but please do it yourself first. Do not just look at the answer key. It's a complete waste of time. Okay, you have to try to do it yourself first. All right, and then I will see you on Tuesday.